Example 1, given x squared plus y squared equals 25, find dy dx. So first, differentiate both sides. All right, so the derivative of x squared is 2x, the derivative of y squared is 2y, and here is our difference. We will have times dy dx. That's why I think of it as the chain rule. Take the derivative of y in there. And then the derivative of 25 is 0. Next, we want to get all dy dx terms on the left and all the others on the right. So in this case, that's fairly straightforward. That would be 2y dy dx equals negative 2x. We'll factor out dy dx if we have to. In this case, we don't have to. And solve for dy dx. So dy dx equals negative 2x divided by negative 2y. Or better put, negative x over y. And let me show what the gravity is here. The big deal here is that x squared plus y squared equals 25 is a circle with a radius of 5. That is what it is. So if I want to find the slope at a certain point, because it's not a function, it doesn't just depend on x. That's what it comes down to. It does not just depend on x. We have to have two coordinates. We have to have an x and a y. So for every given x value, we have two y values. So therefore, we need the whole point. That's why it's negative x over y. We need both of those. So suppose I want to know where the slope on this graph, where the slope is 0, where there's a horizontal tangent line. Well, there are two places. One is the point where at, what is that, 0, 5 and 0, negative 5. Well, if you look at our equation, that is simply whenever x is 0. There happen to be two of those points, but when x is 0. If I want to know where the slope is undefined, that would be these points right here at 5, 0, negative 5, 0, which is where y is 0. Okay, so that is the big deal here. It allows us to do this to find the slope when it's not a function. All right, we're going to hold on to that, and we're going to use that later, actually. So number 2, given x cubed sine y plus y equals 4x plus 3, find dy dx. Well, for the first portion of this, we need to use the product rule. So that would be, I will use this as my u and this is my v. Whenever I take the derivative of something with a y, I'm going to have a dy dx. So u prime v, so that'll be 3x squared times sine y. We did not take the derivative of the sine, so we'll leave it alone. Plus the derivative of sine y is cosine y. So we need a dy dx. We took the derivative of a term with a y in it. All right, times, we don't take the derivative of that this time, just x cubed. Plus the derivative of y, which is dy dx, equals 4 on the right side. The derivative of a constant 0, the slope of 4x is 4. Next, we want to differentiate both sides. Step 2, get dy dx terms on one side. All right, so I'm going to subtract this over. That'll be 4 minus 3x squared sine y. And we have x cubed cosine y dy dx plus dy dx. So did we take care of everything? We moved that term, left that term, moved that one. Okay, there we are. Now we'll factor out dy dx. So that leaves x cubed cosine y plus 1 equals 4 minus 3x squared sine y. And now we will divide both sides by x cubed cosine y plus 1, which makes our dy dx equal to 4 minus 3x cubed. Oh, that should be a squared right there. Sine y over x cubed cosine y plus 1.